Eric Burgess here. A researcher claims that the yearly consumption of soft drinks per person is 50 gallons. In a sample of 47 randomly selected people, the mean of the yearly consumption was 58.2 gallons. The standard deviation of the population was 4.2 gallons. At the 0.1 level of significance, can it be concluded that the researcher's claim is valid? And then we have some steps to follow. Now we're going to be using the calculator method because that's what the steps tell us to use, just so you're aware in case your class uses the chart method. So step 1, state the null and alternative, identify the claim. All right, so we know we're going to have a null hypothesis, that's H naught. Oh, let me switch to black here. H naught, and we're going to have an alternative that's H1. H naught gets an equal sign. H1 we find out from the problem. And here they claim the yearly consumption of soft drinks per person is 50 gallons. So they're claiming that this is the yearly consumption, and that's it. So per year is kind of an indication that we're dealing with an average. So this is that they're claiming that the mean is 50 gallons per year. So the average person, that's what they drink per year. In a sample of 47 randomly selected, the mean of the yearly consumption was 58.2 gallons. So we did an experiment. We found it was different. And our mean was 58.2. I'm just going to write that there just because we've extracted this information from the problem. We had 47 people. And we got a standard deviation of the population. Oh, I'm covering it up a bit. That was 4.2. Now, this is a population standard deviation. So this one's going to be a sigma, and that's 4.2. And then it says at the 0.01, or 0.1, level of significance, so alpha is 0.1, can it be concluded the researcher's claim is valid? So all they want to know is this thing correct? Which means the alternative must be that it's not correct, that this is actually wrong. So it could be wrong it could be lower or it could be higher. They're just saying it's wrong. So we're claiming that the mean simply is not 50. It's something else. It's a different thing. And then along the way, we extracted some numerical information that could prove useful. All right, step 2, identify the tails. Well, to identify how many tails, we simply look at the alternative. Oh, we forgot something. We forgot to identify the claim. So for this one, let's look at this. It says, I usually read the last sentence to tell what the claim is. Can it be concluded that the researcher's claim is valid? So, okay, what was the researcher claiming? Well, the researcher claims that the yearly consumption of soft drinks per person is 50 gallons. So that's the key right there. They're claiming that it is 50 gallons. So this makes our top one the claim. I see a lot of students, they'll automatically put the second one as the claim. Be very careful. The null hypothesis could be the claim. In this case, they're claiming that it is 50, in fact, and so that's going to be our claim. All right, now we're going to identify the tails. So for this, we say, okay, well, we look at the alternative hypothesis. We see that it has a not equals to sign, which indicates that there are 2 tails. Easy as that. Identify the distribution. Well, here we have an n above 30, but the real kicker for what we want is we're using a population standard deviation. And when we use a population standard deviation, we are going to be using a z distribution. If it was a sample standard deviation, then we would use a t distribution, unless you're in a class that has a set value for if n is great enough, then use z. Because as n goes to infinity, it approaches the z distribution. But here we see, okay, we're using the population standard deviation. Because of that, we're going to use a z distribution. Use the calculator to find the test stat and the p-value. All right, well, let's do that. So we know we're using a z-test because we're using a z distribution. So we're going to turn our calculator on. We're going to go to stat, tests, and then the first one, z-test. Easy as that. We are given statistics. These are our statistics right here. We don't have raw data. And for our mu naught, well, our mu naught, we're claiming that it's 50. So we put 50 there. You just put whatever the first one is here, the h naught. And then for our population standard deviation, we had 4.2. For our X bar, well, we had 58.2. We took these out of the problem, and they're coming in handy. N was 47. For the alternative hypothesis, we just want it to match. So not equals 2, not equals 2. That sounds great. And then I'm going to use draw. We're going to hit enter. It's going to draw it for us, but more importantly, it gives us our Z and our p-value in a very easy to understand way. So it rounds our p-value for us and our Z value. So our Z value here is extremely high. Like that's astronomically high. So Z is equal to 13.38 and P is 0. Now it's not really 0. If you go in and calculate it, it's going to be, if you go to the other menu, the calculate menu, it's going to be just a very, very, very small number. If we go to calculate, e to the minus 41. Like, holy cow, is that small? That means there's point and then 40 zeros and then 770,668. It's an insanely tiny number. So our P is basically 0. And so, okay, we've got our test stat p-value. Now we need to sketch it and shade it. So we're going to go ahead and just come in here and, all right, in the middle is 0. Our z-score, so we have two things. We have our test stat, and we're going to have a region above and below because it's a two-tailed test. And this is where our critical values go. So to find our critical value, we're just going to inverse find half of the alpha because, right, half the alpha is here, half the alpha is here. Our alpha is 0.1, so our half of that's 0.05 and 0.05. Because when we add them up together, we're going to get just 0.1. So we're going to go ahead and take our distribution, which is a standard normal. So we're going to go to second distribution, and we're going to go to inverse normal. So 3. And our area is, in this case, 0.05. And then since it's standard normal, mean is 0, standard deviation is 1, because we're doing a standard normal distribution, z-score stuff. And when we hit enter, we're going to get negative and positive, because it's symmetric, 1.64 and negative 1.64. Now our z-score is way out here at 13.38. It's like super in the shaded region. Super, super, super in the shaded region. So now it says to identify our test stat and critical value. We've already found the test stat. That is our, whoops, I'm writing T. Our Z is equal to 13.38. That's our test stat. And our critical value is that Z is equal to plus or minus 1.64. We have one above and below. This one is our test stat. I'm going to write TS for test stat. All right, now we need to decide about H naught. Well, our test stat's way off up here in an astronomical region. So we would say that H naught, we want to reject H naught. We don't think H naught's correct because we are so far away from the safe unshaded region. We are super in the shaded region. So we say reject H naught. We could also say that P is less than alpha, where our level of significance, the shaded region, if we were to put it all together, that was 1, and our p-value was 0, and 0.1 is definitely bigger than 0. So that's another reason we would reject H naught. All right, now on step 8, it says conclude for the claim. So our claim was H naught, which was this one, and we have evidence to reject this. So we would say there is evidence to reject the claim that, and then what's our claim? Well, our claim was that the researcher claims the yearly consumption of soft drinks per person is 50 gallons. So that the yearly consumption of soft drinks per person is 50 gallons. And that's it. That's all we have to say. And after that, we're all done. If you have any questions, let me know, and we'll catch you in the next problem.